That's the bean right here. Here it is. But we're looking at it from mid-sagittal section.
Right.
Okay? And it's intact, and so if you look up here, there's the little channel right there, which is almost already starting to break. So the channel basically comes from the hypothalamus, which is above it, into the pituitary. Okay? Everybody follow that? See that? Okay. So
So it's the connection between pituitary and the hypothalamus.
is the infundibulum. Yeah, infundibulum.
Yeah, I see
Okay?
the big long word.
Right. The I word. Yeah. Okay. Okay. So, okay, where am I? Okay, we need to get to, yeah, we got sidetracked a little bit, but that's okay. So, in this is a half specimen. In the half specimen that I have here, I'm looking at this one, you know, it's kind of chewed up, but I've taken off all of the dura mater, and you see all these blood vessels in here, and they're all collapsed on here, and they're actually captured, because if you look carefully, you'll see in the light hits, it's kind of wrinkly, so wrinkly-like structure on it. And we also see that same scenario in this one. In fact, here you can see some of that tissue right there. I just tore it. And that is the second meningeal layer, called the arachnoid mater. And we have an example, a good example of that in this one. This one has some melanistic arachnoid mater. And basically, I'm just going to lift this up because in life, it's not collapsed like it is here. In living tissue, first of all, the brain is not hard like this. I couldn't do this. It dribbles through my fingers. And secondly, the arachnoid mater is actually floating up underneath, directly in contact with the dura.
So it's similar to the dura, that it's like a barrier.
It's a barrier.
Is it more flexible?
Oh yeah, much more.
Whereas the dura is not.
Yeah, yeah. And the other part that's significant, because this is up against, there's a space here, and I'm just trying not to break this too much. This opening that I'm lifting it up, and there's a space underneath where I'm lifting it, that's called the subarachnoid space. That's significant because that is where the CSF circulates. Okay? And the end of that story is because it's circulating under the arachnoid mater in the subarachnoid space. Those arachnoid granulations that I mentioned before, those little things that we saw that I was pulling up on, are where the arachnoid mater punches through the dura in the superior sagittal sinus and pumps the CSF back through in there. So the arachnoid granulations are formed when the these little granule type structures of arachnoid mater punch through the dura into the superior sagittal sinus, and then they pump CSF into that area along with the blood, and then the CSF goes back into blood circulation. Okay, and what that kind of tells you is the CSF is kind of like a specialized plasma, which it is. Okay, and I want to mention this now because you'll be able to, see this, but the reason that it looks so weird here is because when you add formaldehyde to these, it coagulates all the proteins, and so they just collapse and become very tough. Okay, that's why I can't easily separate this. You just rip it apart.
So it's much larger. If it's a live brain, would the size be larger?
Yeah, it would be somewhat larger because it wouldn't be coagulated, but it would be literally the consistency of oatmeal. So you wouldn't be able to do this. Okay, and also when you open up the dura, then you'd see directly below that would be the arachnoid mater.
So that isn't, with this being two layers, that isn't the arachnoid and the dura? Those two layers that you were looking at?
No.
That's all just
that is
channel?
all the dura. That's a channel in the dura.
That's just the channel, okay.
The sinus.
That's a
Okay.
sinus, right.
Okay.
So basically, here's something that broke off. That's part of the arachnoid right there that pulled off. And so the arachnoid is a separate structure. So here, if I pull on that, you can see it's pulling, and it's still connected to the brain,
Okay.
to the other underlying tissue. Okay? So the arachnoid's a separate layer. Below the arachnoid, CSF is flowing, where in a minute we'll see where that comes from. but the only way to get it back into blood circulation is through the arachnoid granulations, which are protrusions of the arachnoid mater into the superior sagittal sinus through the dura. That make sense?
So it has direct contact with the dura, though.
It pumps through only in those places, not everywhere. Okay, and that's the thing. And in sheep, it's more poorly developed than it is in humans. Humans, it's really cool. You get a good dissection, and you can see the little dots all over the place. You know, it's really, it's amazing. Okay, so where did I go? Okay. So now we want to, the last layer that we need to deal with is the layer, you know, that's below the arachnoid mater. And again, you see these little dark lines here. Those are blood vessels that have been captured by the collapsing arachnoid, which is now congealed onto the top of the brain. Okay, so realize that. If I was to separate the halves of the brain like this, where because the arachnoid doesn't go in between here, if I then look at this region right here, this is gray matter, okay, which is where nerve cell bodies are located, but the outermost layer of this is not neural tissue, it's the pia mater. So the pia mater is not something you can pull apart from the central nervous tissue, okay? It's actually directly in contact. You can see it under the microscope. You can see the layer, the distinct layer that you can see there, but you can't see it here because it's microscopic.
What is it?
The pia mater is these are supporting connective tissue cells that basically help hold all this together.
They're not glial cells.
They're not glial cells per se, no. Not glial cells. So the three meningeal layers are variations of connective tissue. Okay? And they go from very tough to less tough to really delicate. I guess that's the best way to say it. Okay? And the last one, the pia mater, is not something that you can differentiate macroscopically. Okay? It is. If I was to put a pin into this into the cerebrum right here, then the first thing I'd be penetrating would be the pia mater. That makes sense? Okay. So,
From the top, you mean? If you went in from the
well,
top.
even from right here. Even from right here. From the top, if there was no arachnoid there, and that's true, but if the arachnoid's collapsed over it, then I'd be going through the arachnoid, then the pia, then the neurons.
Okay.
Okay. But here, because the arachnoid doesn't go between them, I don't have to worry about the arachnoid right here. So if I just go through right
Is it because
there.
it's a hemisphere? Is that
Yeah,
because
there's a
the
hemisphere.
Okay,
Right.
I understand.
Yeah. So these are two. So we're going to get to that.
Okay.
I'm just trying to deal with the mater. Okay. Okay. So we're going to.
But so the dura mater and
Is it not this one?
Brain.
Say again?
does the dura mater separate the hemispheres or just go
No.
around them?
Well, okay. Yes and no. In sheep, no. In humans, below the superior sagittal sinus, there is a vertical extension of the dura that separates the two hemispheres called the falx cerebri. We have that. We can't see it here, but sheep don't have that. Okay? They have a,
In the arachnoid matter, does that separate the hemispheres?
No.
No.
it goes around them.
But
The falx cerebri.
pia matter.
The pia mater is separate on each hemisphere.
Okay.
So, and the hemispheres aren't in contact.
Okay.
Okay. So, in humans, they're definitely separated via the falx. They call it the falx cerebri because it's an extension. Basically, you have your superior sagittal sinus.